Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem. Problem as usual coming from the book Modern Physics by Kenneth S. Crane. Dear students, this problem is very similar to our previous problem. Now we have come to line spectra of hydrogen atom. Okay, so students or viewers who are watching for the first time are advised to also watch previous video. Okay, because that video is also very much related to this problem. Okay, anyhow, we come to statement. One of the lines in the Brackett series limit equal to 1458 nanometer, nano meaning 10 to power minus 9, has a wavelength of 1944 nanometer. Find the next higher and next lower wavelengths in this series. Okay, one of the lines in the Brackett series limit equal to 1458 nanometer, nano meaning 10 to power minus 9, has a wavelength of 1944 nanometer. Find the next higher and next lower wavelengths in this series. Dear students, before going to its solution in a proper manner, we come to helping tools. Okay, dear students, because this problem is almost a continuation of previous problem, so in this problem we adopt the strategy or scheme that we do not waste time, we do not prolong our video, we try to sum up this solution in a relatively short time. Okay, so helping tool, that is only one tool is involved in this problem, and that tool has been expressed into alternate ways. That is, there are two versions of this tool. Okay, this is the first version and this is the second version, which is after or comes. Okay, so we have discussed this tool in a relatively sufficient length of time in the previous video, so we skip this helping tool. Okay, this helping tool which is being shown on screen has been discussed in previous video, so for the time being we are going to skip this helping tool. Okay, next, I had described in my previous video that this wording, that is, we know that from this to respectively this wording will be repeated in several next videos. So that statement has come true, and this statement, this wording from we know that to respectively has once again been reproduced recopied, repasted in this video, okay, in this problem. And in next videos, next problems, it will once several times again and again be used, because this wording provides a foundation for various problems coming under the jurisdiction of Lyman series, Balmer series, Peston series, Brackett series, and fund series or fund series or fund series. Okay, actually, in my previous video, I have emphasized on this thing that PFU and D fund seems to be a slightly unusual word. So I am of the opinion that perhaps P is silent or F is silent. Okay, so it is either fund or pund, but we assume that nothing is silent, so we have pronounced it as fund series. Okay, we come to its solution. Using n not equal to 4, lambda equal to 1944 nanometer, and lambda limit equal to 1458 nanometer. In equation number 1 we have, why we have done so, we go back. Why going back? Dear students, actually this is Brackett series. Okay, Brackett series is under consideration, and this is Brackett series. Okay, in Brackett series, n naught is 4 while n begins from 5. Okay, this is Brackett series. This is Brackett series. NF infrared, NF is equal to 4 and NI starts from 5. That is one step ahead. So in this equation, because we have said that n naught is equal to 1 is for Lyman series, 2 is for Balmer series, 3 is for Peston series. So n naught equal to 4 is for Brackett series. Okay, so it has become quite clear, because the word respectively has been used. So this arrangement is in a proper order. Okay, so bracket comes at number 4, and hence for Brackett series n naught is equal to 4, and we know that n is equal to n naught plus 1, that is n begins from 5. Okay, for for Brackett series n naught is equal to 4. Okay, because bracket is second last in this sequence. Okay, and hence 4 is also second last in this sequence. So 4 is for Brackett series, and this 4 is equal to n naught, and we know that always n begins one step ahead or one step advance than n naught. So n begins from 5. N naught is equal to 4 and n begins from 5. Okay, so we have done the same thing using n naught equal to 4, lambda equal to 1944 nanometer, which is given in the statement, and lambda limit equal to 1458 nanometer in equation number 1. In order to remove any doubt, we once again go to statement. So what statement says? Statement says one of the lines in the bracket series limit equal to 1458 nanometer. Okay. So in that equation, in equation number 1, where delta limit is written, where there we will use this value, and we will use this value where lambda is written. Okay. This is simply lambda, this is lambda limit. Okay. So once again we go to equation number 1. This is equation number 1. So both those values have been used, one here, and we have already seen that for bracket n naught is equal to 4 and n is equal to begins from 5. So quite clear, nothing ambiguous. Okay, in place of lambda we have used this value, in place of lambda this is equation. Okay, lambda is equal to lambda limit. Okay, so lambda equal to lambda limit. Okay, it means first we have written this which is equal to lambda, and then we have written this which is equal to lambda limit. Okay, so okay, quite clear, nothing ambiguous. In place of lambda we have written this, in place of lambda limit we have written this, in place of n naught we have used 4, and we know that in this case n is equal to 4 plus 1, that is n equal to 5, but we will not use here n equal to 5, because actually we have to find the value of n, and then with respect to this n we will determine what is the next and what is the previous number or wavelength or line. Okay, because in statement it is asked that next higher and next lower. Okay, so in case we know that in case of bracket series where n naught is equal to 4, n begins from 5, but we will not use here 5 or 6 or 7 or 8 or 9. Okay, we will first find the value of n, then we will one time use a value greater than n, and one time we will use a value one step less than n. Okay, so 1944 is equal to 1458 n square over n square minus 16. Actually, dear students, here nanometer will be cancelled with nanometer. Okay, because nanometer is being multiplied on both sides of this equality. So if we divide both sides by nanometer, then this nanometer disappears on both sides. Okay, so this equation reduces to this form. Okay, nanometer is eliminated, and n square over n square minus 16. Okay, next step, what we have done next it will be done that this n square minus 16 which is in the denominator will be shifted to other side of the equality, and it will become in the denominator, and it will be multiplied with this number. Okay, so when this number will be multiplied with this, we will get 1944 n square minus this number will be multiplied with 16. Okay, we have yet not multiplied, we have simply written it as this into this equal to 1458 n square. Okay, quite similar, quite obvious. Now this is also n square and this is also n square. We will shift this n square on other side of equality and it will become negative on other side of equality, while we will shift this factor on other side of equality and it will become plus. Okay, so dear students, we have taken n square common, and so 1944 minus 1458 into n square is equal to this. Okay, when we multiply these two, we get this value. Okay, in the next step, what we have done, we have subtracted actually 1458 from 1944, and hence the difference of this has become equal to 486 n square equal to 31104. Okay, up to this there should be no confusion. Okay, now n square will be left and 486 will be divided on other side of the. Okay, when 486 will be shifted on other side of the equality, then it will become in the denominator. So it will be divided, this figure will be divided by this figure, and hence n square will become equal to 64. Okay, when we divide this thing by 486, we get n square equal to 64, and in the next step we take under root on both sides, so n becomes equal to 8, because 64 is the square of 8, and hence n has become equal to 8. And now, as per statement, we are concerned with one step ahead and one step reverse to 8. Okay, so in the next step, what we will do, we will put n equal to 7 and n equal to 9. Okay, as per requirement of statement. So now, with respect to n equal to 8, we need to put n equal to 7 and n equal to 9 for next higher and next lower lines. Okay, line or wavelength, almost same thing. Okay, so first we put n equal to 7, then we put n equal to 9. Okay, when we put for, this implies that for n equal to 7 we have lambda equal to this into 7 square over 7 square minus 4 square. Okay, so lambda is equal to this, and this becomes equal to 49 divided by 40, it will 33 almost will become. Anyhow, 49 divided by 49 minus 16 multiplied by this factor becomes equal to this factor. Okay, this is almost primary level mathematics. Okay, and this implies that for n equal to 9 we have lambda equal to this into 9 square over 9 square minus 4 square, and hence simplification of this factor gives us lambda equal to this. Okay, so our one value has become this, our one solution is this value, this line, this wavelength, and other value is this line, this wavelength. Okay, 2164.91 nanometer and 1816.89 nanometer. Okay, these were two lines or two wavelengths which we were asked in the statement, and hence we have alhamdulillah successfully solved this problem. And now till next video, Allah Hafiz.